Previously on Ganitam Pathshala.
What's the topic for today? Let's see. Any guesses? What do you expect? Is exactly what you expected. This is the expectation value. This is not the expectation that our parents have on us every day. This is instead the math concept of expectation value in probability.
2,000 years later.
Wait a minute!
People keep asking if I'm back, and I haven't really had an answer. But now, yeah, I'm thinking I'm back.
I am back. Ganitam Part 2. Hi, hello, and welcome back to Ganitam Pathshala. Yes, I know. Since I posted the last, which was the first video of this channel,
It's been 84 years.
but what can we do? It is what it is. I am here now. We are back. So let's get started. So today I wanted to explain the concept, the theorem which all of us surely would have by hearted but not understood in our 11th and 12th, which is the binomial theorem. Even if we had not seen the binomial theorem, at least all of you would have by hearted a plus b the whole square and a plus b the whole cube formulas in the school, writing it hundreds of times. So to explain that formula, all I have today is a pack of M&Ms because I have eaten up everything else. Nothing else is remaining. So let's see how I can explain binomial theorem with these M&Ms. So to understand binomial theorem, first actually we need to know what are permutations and combinations. And luckily I have eaten only few of these M&Ms. So I have enough remaining to create some permutations and combinations. So first let me select some M&M of different colors. Yeah, so I have these 5 with me of different colors and I want to create a permutation of 3 of them. Now what is a permutation? Permutation is simply a linear sequence. So I'm placing the brown, orange and red. So this is a permutation of 3 of the items out of the 5. So I want to create like this permutations and I want to see that how many permutations in all I can form if I have these 5 different colored M&Ms. So to understand that, let us see how are we making each sequence. First, now I have 5 M&M in my hand. To make the first element of the sequence, I pick any one out of these 5 and place it. Okay. Now, given that I have made a choice for my first element, then for the second element I have only 4 choices remaining. So for the first element we had 5 choices, second element we have 4 choices remaining. I pick say the red one and I place it. This is the second element of the sequence. Now for the third element we have only 3 choices remaining. I like the brown one I think, so I'll go with that. So this is my third choice. So this is the way we make a sequence. So for making a sequence we had 5 choices, then 4 choices for second element, then 3 choices for third element. So the total number of sequences that we can make will be 5 into 4 into 3, that is 120.
It was at this moment that he knew. He fucked up.
Now these mathematicians have a very stylish way of writing 5 into 4 into 3. They will write it as 5 factorial divided by 2 factorial. Now this 5 factor is nothing, it is just 5 into 4 into 3 into 2 into 1 divided by 2 into 1, and they write it as 5 into 4 into 3. Now if you'll ask what is all this way of writing, what is this style, then simply
ये बाबूराव का स्टाइल है.
okay. So what we saw was permutations, in which we saw that if you are given n elements and we want to make a R sequence out of it, means in our case we had 5 elements and we want to make a sequence of 3 elements out of it, then the number of ways we can do it is n factorial upon n minus r factorial. In our case it was 5 factorial upon 5 minus 3, which was 2. 5 factorial upon 2 factorial. So yes, that is a permutation. Now we want to see what is a combination. So see, the same 5 M&M I took, of course I ate one blue one, so I changed it, but I have taken again 5 M&Ms and I want to create a combination. So what is a combination? It is basically, again I am selecting 3 elements out of this 5. I am selecting 3 M&Ms out of these 5, but now the order of selection does not matter. Okay, so I have all these 5 elements here and I select any 3. The order doesn't matter, means it does not matter if I first selected blue or then selected red and then orange, or I first took orange, then blue, then red. The order does not matter. What matters is only how many elements I am taking. So that is called a combination. Okay, so to make a combination, what doesn't matter is the order which I am taking, blue, red, orange, or orange, red, blue. The order does not matter. What only matters is which 3 elements I am taking. So out of these 5, which 3 elements I am taking, only that matters. Now we want to find what is the total number of combinations possible with these 5 M&Ms. Means how many sets of 3 elements can I make from this 5 element set. Now we don't need to calculate this explicitly, we can just use some smart trick. So we already know that the number of permutations, which was the linear sequence, number of permutations of these 5 M&Ms was 5 factorial upon 5 minus 3, that is 5 factorial upon 2 factorial. But now see this, for any combination that I take from this 5, say I took the brown, orange and blue, I took this combination, then for every combination how many permutations can I make with this? I can make brown first, then orange, then blue, otherwise brown, blue, orange, otherwise I can start with blue, then blue, brown, orange, or blue, orange, brown, or I can start with the third one and again flip. So for every combination of these 3 M&Ms, I can make 6 permutations, which is basically 3 factorial. So first element in 3 ways, then second element in 2 ways, then third element in 1 way, which is 3 factorial. So for every combination I can make r factorial permutations. Therefore if you want to find the number of combinations, simply we can take the total number of permutation and divide with r factorial, right? Because for every combination we are getting, it corresponds to r factorial permutation. So number of combinations are simply n factorial divided by r factorial into n minus r factorial. In our case it is 5 factorial divided by 5 minus 3, which is 2 factorial, into 3 factorial. So that is the combination formula which you can see here. Okay, so now we want to understand what is the binomial theorem. Okay, so before we understand that, I want all of you to be clear with one intuition. So in our school, when our ma'am or sir would have told us a plus b square for the first time, at least first 1 year they would have by hearted, ma'am, a plus b the whole square is a square plus 2ab plus b square. But after that some sir or ma'am would have thought कि इनको थोड़ा तो समझना चाहिए कुछ, so they would have thought कि let's explain what is this. So we write a plus b the whole square as a plus b into a plus b. Then how we multiply? First we take a and multiply with this a plus b, so we get a into a square, plus a into b, which is ab, then plus b into a, which is ba, plus b into b, which is b square. So we get total a square plus ab plus ba plus b square, which is a square plus 2ab plus b square. So how are we forming each of the terms of this sum? We have a plus b and we have a plus b. Then first we select a from here, a square. We select a from here, b from here, ab, or else b from here, a from here, ba, or else b from here, b square. So now that same thing I will explain for the case of n equal to 3, that is a plus b the whole cube. And luckily I had eaten all them and I was hungry, but I have enough remaining to explain this. Okay, so let's see what is a plus b the whole cube. Okay, so to understand what is a plus b the whole cube, let us think of it same as that a plus b the whole square. We will write this as a plus b into a plus b into a plus b. This is the a plus b, a plus b, a plus b. So first term I am forming by selecting 0 b's, means मेरे को एक भी b नहीं चाहिए. So in how many ways can I select 0 b's out of 3 b's? That is 3c0, which is 3 factorial upon 3 factorial, that is one way. So if I think of all these orange M&M as A and blue M&M as B, then how many ways I can select 0b? That is just one way. I select all the orange and eat it up. The next way, I want to select only 1b. Okay, so 1b and 2a. So in what ways can I do that? I can take from the first BAA, or else I can have ABA, or else I can have AAB. So that is 3 ways, which is again selecting 1b out of 3 different b's, which is 3c1, that is 3 factorial upon 1 factorial into 3 minus 1 2 factorial, that is 3 ways. Similarly, next I want to select 2 b's out of 3 b's. So my term should have 2 b's and 1 a. So in what way I can do that? BBA, or else BAB, or else ABB. Again 3 ways. So that is again 3C2. Lastly, I want to take all the 3 b's. So that I can do only in one way. Take all the 3 b's. That is 3C3. So total what we have, a plus b the whole cube. It is 3c0, which is 1a cube, plus 3c1, which is 3 into a square b, plus 3c2, which is 3 into ab square, plus 3c3, which is 1 into b cube. So this is our a plus b the whole cube formula. Similarly, we can generalize for all n. So what is the binomial theorem formula? That I will show here. We have a plus b the whole raised to n equal to, first nc0, means I take 0 b's, ek bhi b nahi liya, nc0 into a raised to n, plus I will take now 1b, nc1 into a raised to n minus 1 into b. So I take n minus 1 b a's, n minus 1 a's and 1b, then nc2 into a raised to n minus 2 into b square, and so on. I'll go all the way up to, I'll take all the b's, ncn into b raised to n. So that's what gives you binomial theorem. Okay, so hopefully all of you understood what is binomial theorem, and next time whenever you have to use it, you won't get angry remembering a formula, but instead get hungry thinking of all the M&Ms. So to end the video, I will just explain one more small formula which I am sure lot of us would have been troubled by in our high school. That was the n choose k splitting formula, which is displayed here. We can see, we used to see the formula n choose k is n minus 1 choose k minus 1 plus n minus 1 choose k. Now in that always I will get confused where n minus 1, where k minus 1, where k will come. So to explain that now, I am going to show it in a very simple way with again our favorite M&M. I have few remaining thankfully, but after this I think none will remain. So I have taken 5 M&M with me. Let me take the camera a bit down. So I have taken 5 M&M with me, and again out of these 5 M&M I want to select any 4. Okay, I want to make a subset of these 5 M&M, selecting any 4 elements. So think about this logically. In every subset that we make, let me take for example this blue M&M. Okay, now in every subset that we make for 4 elements, either this blue M&M will be there or it won't be not there. To be or not to be, it's either yes or no. In every subset that I form, this will be there or not be there. That is 2 cases. Okay, Now the total ways in which the total number of ways in which I can select 4 elements out of this 5 that we had seen, it is 5C4. But now breaking it case wise, first let us take the case in which this blue M&M is always there. So ये मैं रख लिया. Now remaining how many elements I need? I need 3 elements and I have 4 to choose from. So in the case where blue is always there, the number of ways in which I can choose is 4 choose 3. I have to choose any 3 from remaining 4. So 4 choose 3. I'll take this. ये मेरा 4 elements subset हो गया. Now case 2 is in which the blue will never be there. First case blue is there, second case blue is not there. So blue is not there. I have written it now. So now remaining we have 4 spots and we need 4 M&M. So that is 4 choose 4. In only one way I can form this. I have to take all these 4. So basically what we saw, that n choose k, that was 5 choose 4, is case 1. It is n minus 1 choose k minus 1. The blue one is always there. So that uska spot book कर लिया मैं. तो remaining n minus 1 में से I'll choose k minus 1 elements. n minus 1 choose k minus 1. Second case में blue वाला आएगा ही नहीं. तो remaining I still have k spots remaining and I have n minus 1 elements. So n minus 1 choose k. And if we add both the cases, we have total number. As I told, there are only 2 cases for blue, either yes or no. Therefore we have n choose k, which is the total, is n minus 1 choose k minus 1. Blue is always there, or else n minus 1 choose k, in which blue is not there. Simple. Okay, so that's all folks for today. I'll finish the video here, as I've finished all the M&M also, so nothing remaining to show any more formulas. So that's all for today. Hope you all understood some interesting combinations and permutations, binomial theorem formula, and hopefully now these concepts will be easier for you to process. So yeah, thank you for watching and stay tuned. This is the first episode of 2022. So that's all for this video. I'll meet you next in 2023 only for the next video.
I'm picking up your sarcasm.
Well, I should hope so, because I'm laying it on pretty thick.
I'll leave now. Today it is Sunday here, so I have to clean my room. So my mom has asked me to do pocha in the room. Thank you. Bye.